Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the October 2024 Pure Mathematics P3 International A-Level Edexcel exam. And this question here, we have this curve which is such that the equation of the curve is x equals 2y squared plus 5y minus 6. And we want to find dy dx in terms of y. And this is worth 2 marks. So it's basically, it's a type of what's considered using the chain rule in order to differentiate this. We could use some P4 technique called implicit differentiation, but I think that would be even more complicated than what we're going to do now. So what we're going to do is basically, in P3, what we learn is if we want to find dy dx, and it's difficult to make y the subject of the expression or the equation. To make y the subject would be very difficult here because you'd have to basically complete the square and it'll be a lot of hassle. So instead of having to do that, what we could do is we can basically find what dx dy is, which is quite easy. So we can differentiate the expression with respect to y. So we have x equals 2y squared plus 5y minus 6. And what we're trying to find now is dx dy. Instead of dy dx, we find dx dy. So we differentiate, x with respect to y. So we differentiate each of these terms with respect to y. So you're going to have 2 times 2, which is 4y, plus 5. Okay, so those of you who have done P4, and you know implicit differentiation, okay, you might think, why don't we write dy dx next to these? No, we're differentiating with respect to y. We're not differentiating with respect to x, we're differentiating with respect to y. So that's why you just leave this as 4y plus 5. Okay, now what we can do is, we want to find dy dx, so we just write down this as its reciprocal. So we say dy dx is equal to, so this is like 4y plus 5 over 1, so it's 1 over 4y plus 5. Don't write them as separate 1 over 4y plus 1 over 5. That's not the same. That's not the same at all. So the whole of this, make it into 1 fraction over 1, and then write down its reciprocal. And that's dy dx in terms of y. See, that's dy dx in terms of y. Y is in the answer. So that's part A of the question done. So 1 over 4y plus 5. Let me just write this over here. So we found already dy dx is 1 over 4y plus 5. Okay, we'll probably need this in the next part of the question. So it says the point P lies on the curve and is shown in figure 1. Given that the tangent to the curve at P is parallel to the y-axis, find the coordinates of P. So basically, if you find the gradient of this line, the rise over the run, well, the run is 0. So the gradient will have, it's like an infinite gradient. So the gradient will have 0 in its denominator. Okay, so what we can say is, we know dy dx is equal to 1 over 4y plus 5. Okay, and because the gradient at P, okay, the gradient is undefined. Okay, the gradient is undefined. Why? Because it's a vertical line. So therefore, at P, 4y plus 5 has to be equal to 0. Okay, the denominator has to be 0 for this to be undefined. Okay, so we can say 4y is equal to negative 5. So y is equal to negative 5 over 4. So that's the y coordinate. We want to find the x coordinate. So we take the original equation. We say x is equal to 2y squared plus 5y minus 6. So I'm going to replace the y with minus 5 over 4. So x is equal to, some space here, we're going to have 2 times minus 5 over 4 squared plus 5 times minus 5 over 4 and minus 6. That's going to give you 2 times 25 over 16 minus 25 over 4 minus 6. That cancels with that, gives you 8. That's 25 over 8 minus 50 over 8. That's minus 25 over 8. and that's minus 6. So if you put here, that will be 6 8s are 48. This will be minus, that's 60 minus 73. Okay, minus 73 over 8. So the x coordinate is minus 73 over 8, and the y coordinate is minus 5 over 4. Okay, they're both negative. Okay, that looks right. Yeah, that looks about right to me. And there we have the answer to part B. And I think that's the end of the question, is it? Yeah. Okay, so there's the answer to the question, part B. Okay, so this is about differentiation, this topic, I guess. And we have the first part of it is, it's kind of like related to what's called the chaining. Okay, but that's fine. So that's the answer to question number 2. Other questions from this particular paper can be found in the playlist, which will appear in the top right of the screen at the end of this video. Other questions from the topic of differentiation from P3. Okay, and I'll put this under the chain rule, okay, because it's classified under the chain rule. Part A is at least. And you can subscribe to my channel by clicking on this link. And at the top here, you can see a video which tells you how to use my channel effectively. Thank you for watching and see you soon.